Hello, in this video we're going to talk about modeling with differential equations. So I want to make sure that we go back and we understand how to recognize a differential equation and what really a differential equation is. So let me go ahead, and this is a little bit large. So let's go ahead and discuss a definition. And in this definition, we're going to determine what is a differential equation. So basically, a differential, I'm just going to abbreviate it, equation. A differential equation is an equation. It's an equation of one or more derivatives of some unknown function. So I always tell people that differential equations is just a strong or a different way of looking at algebra. Instead of us solving for an unknown variable, we're trying to find an unknown function. So we're trying to find an unknown function. So when we look at this, we want to determine the unknown function. The way that I like to denote the unknown function, the way that I like to denote it, and this is not specific to just this class, but it's more of an opportunity that we define in this class, is that we'll define it as y equals to y sub x. And this is going to be a differential equation. And if time is involved, and we know time is a very important variable, then we're going to note the differential equation as y equals to y of some function of t. So if we see it denoted y equals to y of x, then we know that this is an unknown function that does not involve time. If it's y equals to y sub t, this is going to be an unknown function where time is a variable. So now let's go ahead and discuss the order of a differential equation. So the order of a differential equation. I know that some people already have this pre-typed out. I like to write it out so that way I don't get too far ahead of myself, and I want to make sure that everyone that's working along with us can also write this out at the exact same level. So I write everything out, and hopefully that helps you make more sense. So back to the order, this definition of the order of a differential equation. And this, it actually sounds a little bit more complex than it is, but all it is the value of the highest derivative. So the order of a differential equation denotes the highest derivative that it contains. So the order is equal to the, I guess we can call it magnitude, we can call it the magnitude or the highest derivative it contains. So let's look at some examples. Let's look at some examples. Let's say we say dy over dx is equal to 3y plus 2. So if we want to identify the order of this differential equation, the order of this differential equation is indicated by the derivative, the value of the derivative. And this right here is a first derivative. Therefore, the order of this differential equation is equal to a value of 1. So let's go ahead and look at another example. I always think these are sort of fun. So it's always something that's nice and relatively easy. As you advance and go into partial differential equations, you realize that not only do we look at the order, but also the type of differential equation. For right now, we get to stick with just the nice, easy order. So let's say we have dy dx plus 3d squared y all over dx squared plus 17y, and this equals to 0. So let's go ahead and evaluate this and see what we have. Notice here this is a first derivative, this guy is a second derivative, and this is no derivative at all. This is not a derivative. This is just a value of y, so no derivative. So I can even write that, no derivative. Therefore, we look at the largest value, the largest derivative, and we realize this is going to be a second derivative, so that's going to be an order of 2. So again, I think this is relatively really nice, something that's easy to work with, nothing that's too complex. So let's go ahead and look at maybe 2 more examples. Let's go ahead and look at 2 more examples. Let us look at y double prime plus y prime plus 3y triple prime is equal to 2. Let's look at 2 cosine of 3t. 2 cosine of 3t. So hopefully we see here this is now a function of t, so all our derivatives will have a value of t. When we evaluate this, this is a second derivative. This right here is a first derivative. And this guy right here is a third derivative. So since we have that value of the third derivative, since we have that third derivative here, the order of this differential equation is going to be equal to a value of 3. So again, nothing that's too complex, nothing that's too difficult for us to evaluate, but this is going to be an order of 3. Let's try something that's a little bit different. So let's go ahead and look at this guy. Let's say we have y plus 2y squared equals to 3 sine of, let's say 3 sine of y. So notice here, do we see any derivatives involved in this equation? I do not. I see y squared, I see sine of y, I see no derivatives, so this in fact has an order equal to 0. So there are no derivatives in here. This is not a differential equation. We don't have to solve for an unknown equation. We're looking for an unknown variable, and in this circumstance, it's a value of y. But if we were looking for an unknown equation, that would have to be in the form of a derivative, and we would know that we would have a differential equation. So that's going to be a relatively easy way for us to determine the order and just to define the differential equation in a way that makes sense. So hopefully that helps you. I definitely recommend practicing and going through some of these and making sure that you understand them. And I look forward to continuing.